Hello, I'm Lucas, and today I will be talking about Cushing syndrome. Okay, let's be clear. Cushing syndrome describes someone with prolonged high levels of cortisol. Moreover, people with Cushing syndrome don't obtain these abnormal cortisol levels, randomly, but rather by specific underlying causes. These include steroid abuse, tumor on adrenal glands, tumor on pituitary glands, and many more. But for this project, I will focus on the specific scenario of a tumor on the pituitary gland and how this specifically leads to Cushing syndrome. So let's jump into the science. The three ligands relevant today will be corticotropin-releasing hormone, aka CRH, a water-soluble hormone. Next up, adrenocorticotropic hormone, aka ACTH, a water-soluble hormone. Lastly, cortisol, aka cortisol, a steroid hormone. These three ligands are part of the hypothalamic pituitary axis, aka HP axis. It's a stress pathway. One of its main processes is producing cortisol. Now, I will outline how the HP axis works to signal cortisol production. So when the hypothalamus, which is part of the brain, detects stress, the cells in the hypothalamus secrete CRH, and this travels via blood vessels to the pituitary gland. And in response, the cells in the pituitary gland then secrete their own type of ligand. This is ACTH. ACTH travels via blood vessels all the way down to the adrenal glands, specifically the adrenal cortex part of the adrenal glands, where the cells in the adrenal cortex secrete cortisol, and cortisol travels via blood vessels across the entire body. And so, the cortisol gets into nearly every cell in the body, triggering a widespread stress response. Within this system also exists a negative feedback loop. And how this works is cortisol that was secreted all across the body also ends up in the pituitary gland and the hypothalamus, which, when taken in by the cells, signals to them to shut down production of their signaling hormones, effectively stopping signals to the adrenal cortex to produce cortisol. And now, starting from the top, I will go into depth. So now I'll be looking on the cellular level how CRH comes from the hypothalamus to the pituitary gland. So as you can see, there's a G protein coupled receptor, specifically CRHR1, which the ligand of CRH comes and attaches to. Once it's attached, this induces a change on the cytoplasmic side, and this activates a G protein, causing it to output GDP and intake GTP. This effectively will power the G protein and allows it to move along the membrane and towards adenylyl cyclase, where once it binds to adenylyl cyclase, ATP gets converted to CAMP, the second messenger. And CAMP activates protein kinases A, which triggers a phosphorylation cascade. And then ERK1/2 is the last kinases in the chain, and it is the one that sends the signal to the nucleus. This results in transcription factor causing secretion of ACTH in the pituitary gland. So next, we're looking at how ACTH from the pituitary gland gets to the adrenal gland / the adrenal cortex. So here we see a G protein coupled receptor, specifically MCR2, which is meant for ACTH. And so ACTH comes and it binds to MCR2. This induces the change, triggering the G protein. Same thing, outputting GDP and intaking GTP, allowing it to move along the cell membrane towards adenylyl cyclase. This activates adenylyl cyclase. It converts ATP to CAMP, the second messenger again. And this triggers protein kinases A, which then directly signals the nucleus. This activates a transcription factor signaling cortisol secretion. Last of the three. Cortisol to body cells, including the pituitary gland and adrenal glands. So here we have cortisol, and since it's a steroid hormone, it can passively diffuse through the cell membrane. And cortisol binds to intracellular receptors, specifically glucocorticoid receptor. Once it's binded, it forms a GR complex, and this GR complex itself moves towards the nucleus and acts as the transcription factor. So that's what normally happens. But in the case of a pituitary gland tumor, the mutated cells in the pituitary gland autonomously produce ACTH without a signal at all. The negative feedback loop becomes ineffective and is ignored, and therefore cortisol is continuously signaled to be produced by ACTH. So, cortisol is necessary and beneficial when signaled correctly. But when the pathway is tipped off balance and cortisol is too high for too long, the needed elevated heart rate, slowed metabolism, increased blood sugar, decreased inflammation becomes increased inflammation, unbalanced fat gain, hypertension, and much more. So next time you're stressed for an assignment, know it's your cortisol. Thank you.